I'm gonna do a talk about generating a GraphQL backend with Golang. Um, so first, some little things about me. I'm also a software developer here. When I started working here, I started with setting up Kubernetes for our projects. After that, I worked on the car sharing platform that was talked about, and now I'm working mostly on code generation. So that's what this project is also about. Next to working here, I'm a computer science student at the Technical University in Delft, where I'm doing my master's now. And in my time left, I sometimes go snowboarding and skateboarding. So in the beginning, there was REST, or well, not really in the beginning, but that's what everybody uses today mostly. With REST, you most of the times do something like this, like do a GET request to an endpoint which defines your models or what you get back. The result is always predefined. You can, or most of the time. So you can first get the user, for example, and if you want to know what kind of posts this user has posted on, for example, a social media platform, you can you can do a GET request to the user slash ID slash posts endpoint to get all the posts of this user. And then if you want to see the comments on one of the posts, for example, you do another request, and so on and so on. What if we could just ask for the fields that we're interested in, because there was also a created ad field, and maybe we don't really want that field at this point. And what if we could combine resources, because for now we had to do a call for all the users, then for each user do a call for the post they posted, and then for each post do a call for the comments on this post. And what if we could know in what kind of form the result is returned? So now you get some JSON blob back, but what if we already know all the types of everything you can get back? So Facebook a couple of years ago created GraphQL. Here you have a single endpoint in comparison to REST with multiple endpoints. You can do queries and mutations on this endpoint in comparison to get, post, put, and delete. You can define what you want to get back, so the response is flexible, where in REST the response is hard-coded. And you can follow relationships, so in the case of the post, you can already get all the comments on a post in one call, where in REST you should do multiple calls to endpoints, or make one big endpoint which results all the data that you want. And in REST, each query is most of the times executed in multiple resolvers for each field and model, where in REST you have one route handler which defines what you get back. So this looks something like this, where you have a query. You can say, okay, give me all the users with their name and the posts of these users with the title, content, and the comments, and which user posted the comment. But you can also combine multiple queries in one. So here you can get all the users and all the posts of all the users. Well, this is defined by a schema. So you define what your query and mutation results are. So which types you can query and which types you can mutate. This looks something like this in our mini social media example. So as you can see, all the types are predefined. This is visible to the client or the front end that you're writing. So you can already know which types you can expect back if you're doing a query. So that's also, yeah, that looks really nice and well, real great. But what about the backend? So for that we use GQLGen. GQLGen expects a schema like this, and then it generates code for Go, from which you can start up a complete backend basically. All you have to do is implement these interfaces. So there are still quite a lot of interfaces that you have to implement, especially if this is quite a small example, of course, and you already have to implement all these interfaces with their functions. It looks something like this. For example, for the mutation resolver, there's a function create post. Okay, so you already know what kind of input you get, convert it to a model, check for authentication stuff, and then you create the model in the database. And then you return the model because the client expects this data back. So, well, yeah, now we have to implement all those interfaces and all those resolvers. Quite a lot. So we thought maybe we can do this smarter or more efficient. We already were using a code generator for our models, which we used like this. We have the file with a design. This is then the design. So you define a store and all the models in it and the relations between them. This already generated all the models, the relations between them. So there were some functions where you can easily get all the posts for a user if you had a user. So we were thinking maybe we can just extend this code generator by adding some more functions. Because we wanted to generate the complete GraphQL backend, including authorization and stuff. So here you can see for which actions, what kind of authorization rules there are. So for creating a user, of course, we are using scopes, by the way, for users. So every user has a scope which defines which kind of actions a user can take. So for creating a user, you don't need a scope because otherwise it's pretty hard to enter the system anyway. So in this case, for the social media example, also the scope for reading users is open, but for updating, you can only update if you're logged in as your own user. So this makes sure that you can only update yourself. Same for delete. So then if you implement this for all the models, you get something like this, where you can only update a post if it has your user ID. Same for delete. And for the comments, it's basically the same. And you can see all these relations to the rest of the models. I want to show you how it works in practice. Okay, so basically you only have this, the design, and some main file which starts up the backend. This is the GraphQL endpoint. This is some playground handler where you have a web view where you can put in the queries, which you probably won't use in production, but nice to test things. That's basically all you need. This generates a complete working GraphQL backend in Go. So I can show you how that works. here you can, for example, create a user like this. I already created this user, so this is gonna fill if I do it again. But yeah, you can put in the input here, and here you can define which fields you want to get back from this created user. So after that, you have to log in. The generator also creates a JWT mutation by default. So this is where you can log in to the backend. Then you get a JWT token back, which you can use for your next queries. So you put that in here in the. Okay, so this is like a autofill function of this client. But this is how you put in a JWT token. And then you can go and do queries on the database. So, okay, this is not this is supposed to work. Yeah, always nice, live demos. Well, now, the result that's supposed to come back is already there, so you can still see how it works, I guess. So it works like this then. You can do a query for a user with a specific ID. You can define which fields you want to get back and the posts of this person with a title. I already put some stuff in the database for this demo purpose. And there's also by default me query generated, which always returns the logged in user who is doing the request. So here you can see how a create post mutation look like. In the previous queries there was query here, now there's mutation because you're doing different stuff. That was also already in login and create, by the way, but well. And the same way you can just ask for the fields you want to get back, and there's no predefined result. And if you're developing, for example, your front end in JavaScript or TypeScript, you can also generate types from the schema that is provided by the backend. So you can build a totally type-safe front end based on this schema. Well, and you can do like this and go levels deeper. Okay, well, maybe that still doesn't work. Okay, well, that's too bad. But you can, I think you get the idea. And here you can see the multiple query stuff. Okay, there's a lot of more that you can do with this generator I created, but I don't really have time to go over all of it. But you can also check for relations with parent models. So for example, if you're going a couple of levels deeper, then you can say, for example, only get the comments if the name of if the user ID of this comment is the same as the user where we're querying from. These kind of relations can be really handy in real life production cases. Yeah, there's a lot of more stuff you can do with the generator, but well, talk to me after the meetup, I guess. So that's it. Are there any questions? Yeah, sure. Okay. So we have, for example, the post resolver here. So this has the create post function in the mutation, and this is then what gets generated. So there's also the authentication for all the mutations is also generated, as you can see here. It checks this for autofilling. That's also a function that I added. So if you're creating objects which need a user ID, and if you don't provide it, it will autofill in your own user ID. And this is the authentication stuff, where you check if a user has a specific scope, and if it hasn't, access is denied. This is more interesting, I guess, in reading. So, okay, wait, that's here. Oh yeah, that's open, so there's nothing generated here. But okay, this is like how it's generated. You can check for the scope, and if there is a parent relation defined, also that is generated and checked. But I don't have that in my example, so you can't see it here, unfortunately. So. Yeah. I think it's not working now because my backend is failing. But normally you have it works. So you have autocompletion here in the client as well. So here you can see that it knows which fields you can query. Yeah, you have to define everything in your schema. So if you're doing like not CRUD stuff, that's what I can't generate, of course, because I can't know what you're gonna do with all your models. But I have implemented also some functions which you can see here. So you can, for example, do a before create and then give it a name. Log, for example. And then it generates an additional method in the interface that you have to implement by yourself, of course. But in this way, you can do some extra modification or extra actions like logging, create, or something like that. But I don't really see any downsides to using GraphQL over REST, actually. Not that I can think of. Okay. Yeah. Yeah. Yeah, that's true. At this point, this is still also the case in my generator, but there are solutions to this which I don't yet have implemented, but where you can combine all these queries and give a list of IDs to the database and get all these objects in one. Ah. Yeah. 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 Yeah, exactly. Yeah, I don't have implemented that yet, but that's on the to-do list. Yeah. Ah. Um, I'm not entirely sure actually, because that's handled by the GQL generator. That's that I use, but I don't develop it. So that depends on the GQL gen, but it's quite heavily used now by developers were using GraphQL and Go, so I guess that they use it, but I don't know for sure. I can't tell you. Any more questions? Thank you.